Good morning, students. Chapter 5, Laws of Motion. Yes, in last lecture we have discussed about what is friction, okay, and what is static friction. Clear? Friction, yes, it is parallel component of contact force to contact surface. Another component is perpendicular component, which is called normal force. In last lecture, we have discussed about static friction for a block placed on horizontal plane. Placed on horizontal plane. But if you are given a block when it is placed on inclined plane, then what happens with it? See, for example, yes, it is horizontal. It is horizontal. Okay, yes, it is horizontal. Okay, and yes, with this horizontal, if it is one slope which is inclined at angle theta. Clear about this? Yes, it is horizontal. With this horizontal, it is one slope having inclination angle theta. And on this slope, on this inclined plane, one block is placed. One block is placed. Clear about this? Okay. So yes, it is situation given. K, one block is in rest condition, is placed on a slope. On a slope. Okay. At which is inclined at angle theta with horizontal. Okay. So yes, here I will write. Here I will write. See, here block is at rest on slope having inclination angle theta with horizontal. Clear about this? Okay. In last lecture we have discussed when block is placed on horizontal surface, but now it is placed on inclined surface having angle theta. Clear about this? Now, first of all, you have to identify numbers of forces acting. Chalo, first, as it is block having some mass, so its weight is always acting in vertically downward direction. So see, if mass of this block is m, then from this point mg, that is weight, it is always acting in vertically downward direction. So we can say that this block exerts force equal to its weight on this inclined surface. Clear about this? Then yes, okay, block exerts force mg on inclined surface. Clear about this? According to Newton's third law of motion. Remember last theory, first statement. When two bodies are in contact forces are produced and they are always in pair. So yes, as this block exerts force mg on inclined surface. Yes, inclined surface exerts force, reaction R on block. Okay, inclined surface exerts force, which is called reaction R on block in this direction. See, in this direction, it is called reaction R. Clear about this? So again, block exerts mg force on inclined plane, inclined surface. This inclined surface exerts reaction R on block according to Newton's law of motion. Yes, they both are in opposite direction. Clear about this? Clear about this? Okay. Now, yes, we have two forces. We have two forces. Now what will we do? See, this R is called contact force. This R is called contact force, and now we will resolve this contact force in two components. Now we will resolve this contact force in two components. One parallel to contact surface, another perpendicular to contact surface. Clear about this? So see how to resolve this R in two components. Now we will resolve R in two components. Resolve R. R means it is nothing but contact force. Contact force in two components. In two components. First component, perpendicular to contact surface. Perpendicular to contact surface, and it is called perpendicular to contact surface is called, yes we know, is called normal force. Is called normal force denoted by N. Clear about this? And another force is parallel to contact surface. Parallel to contact surface. Parallel to contact surface. And yes, is called parallel to contact surface. Is called friction. Is called friction denoted by small f. Denoted by small f. So again, two bodies are in contact with each other. Contact forces are produced. Resolve R, that is contact force, into components. Perpendicular to contact surface, that is called normal force, and parallel to contact surface, which is called friction. Now see here it is. How to resolve these two components, or how to write them, See how to indicate these two components in figure. Take care about this. Here it is. It is called contact surface. It is called contact surface. Yes or no? Yes, it is called contact surface. Okay. So see, here it is. It is R. You have to resolve this R in two components. You have to resolve this R in two components. One parallel to contact surface, one perpendicular to contact surface. Perpendicular to contact surface means like this. See, perpendicular to contact surface, it makes angle 90. So yes, it is called normal force N. It is called normal force N. Clear about this? Clear about this? Yes or no? Yes. So perpendicular to contact force is called normal force. Clear about this? Okay. Second is parallel to contact surface, which is called friction. Parallel to contact surface, which is called friction. And yes, it is in this direction. It is in this direction. It is in this direction. Okay? Yes, it is called friction. It is called friction. Clear about this? Clear about this? Yes, it is called friction. Any doubt? So yes, resolve this R in two components. One perpendicular to contact surface, one parallel to contact surface. Now you may ask, okay, why this friction is acting in this direction? Parallel to contact surface means it is also possible in this direction. Yes or no? Yes. Parallel to contact surface means we can assume two directions, one this side and one this side. Then why we have indicated friction force in this direction? Because assume if there is no friction, then what would happen with this block? Obviously, this block will slip down. Yes or no? This block will slip down. Yes or no? Yes, it is. When there is no friction between block and this surface, this block will move in downward direction. Yes or no? So yes, in absence of friction force, block would have been slipped down. It is called impending motion. When friction is absent, motion of object is called impending motion. Clear about this? So see, here it is. Okay, when friction is absent, okay, in absence of friction, block would have slip down, okay, slip down, incline plane. Okay, so yes, this block would have moved in this direction, yes or no? And it is called motion in absence of friction. Motion in absence of friction is called motion in absence of friction is called impending motion. So if there is no friction present, then yes, obviously this block would have been moved in this direction. So it is direction of impending motion. And remember, friction is in opposite direction of impending motion. Friction is in opposite direction of impending motion. Friction is in opposite direction of impending motion. Clear about this? What is impending motion? If friction is absent, okay, if friction is absent, then yes, in this case, okay, in this case, motion of object is called impending motion. Clear about this? Okay, now again, block on inclined plane having inclination theta. Yes, here it is. Force exerted by block on inclined surface, mg. Force exerted by surface on block, reaction R. Resolve R means contact force in two components, perpendicular to convex surface, normal force, here it is. Parallel to convex surface, friction, here it is. When friction is absent, block would have slipped down inclined plane. Motion in absence of friction is called impending motion, and friction is in opposite direction of impending motion. Clear about this? Now, one important thing. We are assuming x-axis parallel to slope. Assume let x-axis is parallel to slope. So what is meaning of this? Yes, it is x-axis. Clear about this? Yes, it is x-axis. So yes, obviously y-axis is perpendicular to it. So it is y-axis. Clear about this? Again, let x-axis is parallel to slope. So obviously it is perpendicular to it, so it will become y-axis. Any doubt in such questions? Yes, you have to assume x-axis parallel to slope and y-axis perpendicular to slope. Clear about this? Now see here. Initially there are two forces, mg and r. Now as we have resolved this r in two components, now we can say we have only three forces, mg, f and n. If you consider r, do not consider n and f. If you consider f and n, do not consider r. Clear about this? Okay. So yes, here there are three forces, mg, f and n. Clear about this? Now see, this friction force is along x-axis. Yes or no? Yes, it is. This normal force is along y-axis. Yes or no? Yes. As we have considered normal force and friction force, now we do not have to consider this reaction force, because yes, components you have considered means it is R. Okay, so now we have mg, f and n. Again, f is along x-axis, n is along y-axis. But what about this mg? What about this mg? It is not in x direction. It is not in y direction. So remember students, if you are given numbers of forces, identify which forces are in x direction, which forces are in y direction. You do not have to resolve such forces. Resolve the force which is not in only x direction, which is not only in y direction. Here f is along x direction, n is along y direction, but mg is not in x or y direction. So yes, we have to resolve this mg. How to resolve this mg? See, yes, it is mg. So I will resolve this mg into component. One parallel to slope and another perpendicular to slope. Clear about this? Again, this component is parallel to slope and this component is perpendicular to slope. Okay, so yes, out of these three forces, that is mg, f and n, why only mg is resolved? Because this mg is not in x direction or not in y direction. So yes, we have to resolve this mg. Now, to find components, we need angle. See, this mg is in this direction. Yes or no? This angle is theta. This angle is 90. Then obviously this angle will become 90 minus theta. Yes or no? Yes. This angle will become 90 minus theta. This angle means I can say this angle. It will become 90 minus theta. Clear about this? Yes, here I will write it is 90 minus theta. It is 90 minus theta. So these two are perpendicular to each other. Obviously this angle will become theta. Again, see, mg in downward direction. See this right angle triangle. This angle is theta. This angle is 90. So obviously this angle will become 90 minus theta. As this angle is 90 minus theta, this angle will also become 90 minus theta. These two are perpendicular to each other. If it is 90 minus theta, then it will become theta. Clear about this? So yes, now you have to remember directly. It is angle theta. Now this mg makes angle theta with this component. So it is called mg cos theta. And yes, obviously this component is called mg sin theta. Clear about this? So yes, you have to resolve this mg into components. Perpendicular to convex surface mg cos theta, parallel to convex surface it is mg sin theta. Now see this statement. When friction force is absent, this force is 0. Then on this block in x direction there is force mg sin theta, and due to mg sin theta this block would have slipped down inclined plane. Clear about this? But actually there is friction present. So this mg sin theta is balanced by this friction force. Clear about this? So yes, it is diagram that you have to draw and understand perfectly. Clear about this? Again, first of all mg, which is always in downward direction. Now we will not consider r. We will directly draw normal force and friction force. Because if you draw these two forces, they are components of r, so you do not have to draw r. Okay. Now parallel to x, it is parallel to slope x-axis, y-axis. In x direction, in y direction, not not in x or y, so we have to resolve mg cos theta and mg sin theta. Clear about this? Now see this statement. Here block is at rest. Block is at rest. Block is at rest. It means it is in equilibrium. It is in block is at rest. It means it is in equilibrium. It is in equilibrium. It is in equilibrium. It is in equilibrium. Equilibrium means sigma f is equal to 0. Equilibrium means sigma f is equal to 0. And if you remember, sigma f is equal to 0 means sigma fx is equal to 0 and sigma fy is equal to 0. Clear about this? Sigma f is equal to 0 means sigma fx is equal to 0 and sigma fy is equal to 0. Now see, you observe in this figure. Here it is. See. It is x direction. Yes, we have assumed x-axis is parallel to motion. Now, identify numbers of forces acting in this direction. Means parallel to slope. Means parallel to slope. See, there are two forces acting. See, there are two forces acting in this direction. Parallel to slope. First is friction and second is mg sin theta. Clear about this? Parallel to slope. Parallel to slope. Two forces are acting, F and mg sin theta. From figure it is clear, they both are in opposite direction. They both are in opposite direction. So yes or how to write? How to write? Sigma fx is equal to 0. Means resultant of these two force is 0. Resultant of these two force is 0. How to write? How to write? mg sin theta. Mg sin theta. Mg sin theta. Here it is. Friction force. It is in its opposite direction. Mg sin theta and friction force, they are in opposite direction. So here I have considered mg sin theta positive. Then I have to consider this friction as negative. Is equal to 0. Is equal to 0. Clear about this? Clear about this? Why minus sign? Because mg sin theta and f, they both are in opposite direction. Or you can also write this as mg sin theta is equal to f. Mg sin theta is equal to f. Yes, this equation is easy to understand. See, this block is not moving in rest condition. Means force acting on one side is equal to force acting on another side. Clear about this? Clear about this? Force acting on one side is equal to force acting on another side. Mg sin theta is equal to f. If I am here and some two persons are pulling me with the same force, then yes, that object will be stationary at that point, because from two sides, two forces, opposite direction. So resultant force will be 0. Clear about this? Yes. So what is meaning of sigma fx is equal to 0? Mg sin theta minus f is equal to 0, or mg sin theta is equal to f. Clear about this? Okay. Now sigma fy is equal to 0. Where is y-axis? Here it is. It is y-axis. It is y-axis. It is y-axis. Forces acting in y direction 2 n and mg cos theta. N and mg cos theta. Object is at rest, equilibrium condition. So sigma fy is equal to 0. So again I can write n and mg cos theta. I can write like this: mg cos theta minus n is equal to 0. Again, why minus? Because mg cos theta is in this direction and n is in opposite direction. It is in opposite direction. Yes, you can also write this equation as mg cos theta is equal to n. Again, see, force acting in one direction is equal to force acting in another direction. Clear about this? Clear about this? Then see, whenever object is at rest in equilibrium, it is simple. It is simple. First of all, resolve forces parallel to x and y axis, block in x direction. Okay, so simple. If it is at rest, force acting in left hand side is equal to force acting on right hand side. Clear about this? Okay. If it is at rest, then forces acting in this upward direction means along y axis, forces acting in downward direction means along negative y axis. axis. Simple. See, mg sin theta is equal to f. One side is equal to other side. For another equation, mg cos theta is equal to n. Up is equal to down. Clear about this? Okay. Now, see, if I am taking ratio of these two equations, that is mg sin theta upon mg cos theta is equal to, it is f upon n. mg cut, sin theta upon cos theta, it is tan theta. Then yes, tan theta is equal to f upon n. Tan theta is equal to, it is f upon n. This equation you have to remember. This equation you have to remember. Okay. F upon n is equal to tan theta, where theta is this angle. Where theta is this angle. Clear about this? What is small f? Friction force. What is n? Normal force. And theta, that is angle of inclination. Angle of inclination. Clear about this? So yes, in last lecture we have discussed what is friction when object is placed on horizontal plane. And now in this lecture we have discussed about, okay, what happens when object is placed on inclined plane. On inclined plane, you have to remember this equation. Tan theta is equal to f upon n, and the most important thing is this figure. This figure. Clear about this? Yes. Write down and make your notes.